Let's start back here on dear old planet Earth. Let's go back in time to the early 1960s. Maybe a few of your audience were around at that time. I certainly was. I was driving a Land Rover to India, as it happened, in the early 1960s. I spent a year in Calcutta teaching, came back to the UK for my 21st birthday and stayed here ever since. I've been trying to get out. I have been back to India, I've been to Japan and South Africa, so I've been around, but I've never been to North America, which is a big problem because a great deal of research and information specifically about the Apollo program is something I'd like to see on the ground, to see in real life. I'm sure there's a great deal I could learn, because I'm going to make a statement now, and if anybody can prove me wrong, I would like them to do so. The statement is very simple. No human has ever walked on the lunar surface. That's where we're starting from. Now, how can I support that sort of antagonistic statement? Because those of us who were around at the time, and I was certainly one of them, and I'm sure a lot of your audience were, watched those famous landings on the moon on July the 20th, 1969, when Neil Armstrong and Buzz Aldrin climbed down from the lunar module, the Eagle, walked onto the lunar surface. And Armstrong made his famous statement,
"It's one small step for man, one giant leap for mankind."
And we all believed him because we all saw it. We saw it live on television. This was live, don't forget. This wasn't recorded. This was live transmission from the lunar surface. And that's the first problem. How on earth did they do a live transmission from the lunar surface? Any electrical engineer can tell you quite easily how much power is required to transmit a signal, a radio signal, a TV signal here on Earth. And it's about 30,000 kilowatts. They didn't have 30,000 kilowatts. They had 3,000 watts. 3 kilowatts was available for the power. So that's the first problem. How on earth did they do that live transmission? Now, we all watched that, and everybody saw the same thing. So we all reckoned that it's part of our memories. Our memories say, yes, we watched that landing live on the moon, and we watched them come back, and 3 days later, July the 24th, they landed back in the Pacific on the end of their big parachutes, the red and white parachutes, and they were heroes, and they went around the world and met presidents and kings and prime ministers and popes and heads of this and heads of that. Of course it had to be real. You can't fake something like that. No, that was very real. All that was very real. And some of you may remember the famous discovery in the Rijksmuseum of the fake moon rock, which was alleged to have been presented to the then Prime Minister of Holland by Armstrong and Aldrin to commemorate their visit to Amsterdam in 1969. Unfortunately, they couldn't have presented any moon rock to anybody at that time. It was all still held in quarantine at Houston. So the whole story was a wonderful piece of fiction because it turned out to be a piece of petrified wood. Very strange, that. Things like that crop up. These stories sort of come up over the years. That happened about 10 years ago.
I just want to stop you there for a second.
Yeah.
Why did you take such an interest in this? I mean, you watched it as a kid, you believed it. What 10 years ago, what lecture did you hear 10 years ago that changed your entire vision of what happened?
It was actually about 25 years ago. And one of them is a series of lectures which has been going on now for nearly 30 years. It's called the Glastonbury Symposium, normally held at the end of July. They were talking about megaliths, ancient structures. And the person giving the lecture was talking about all these weird and wonderful structures. And he was talking about the photographs, showing a lot of photographs. And almost as an aside, he said, well, of course, you've probably seen those photographs taken on the moon. Well, they weren't taken on the moon and couldn't have been taken on the moon. Now, he didn't expand any more than that, but it piqued my interest because I had studied photography. Following my trip out to India, I'd taken a lot of photographs out there. I wanted to find out more about the technical side of photography. So I went to college for a couple of years in London to study photography, specifically the technical side of it, not what photographs to take. Now, I'm talking about photographic film here. A lot of people won't even seen a photographic film. But in the 1960s and 1970s, photographic film was what was used to record images. Nowadays we use digital. But in the 1960s, they hadn't been invented. So everybody had to use photographic film. Now, photographic film is a strip of plastic-backed gelatin, which is light sensitive and records images by the amount of light that comes into the camera. You develop the film, and if you're using black and white, you develop it into a negative, and you then print that into a positive image to get the image that you'll then look at. So I wanted to know how to go about ensuring that I could use photographic film effectively. I worked professionally in studios in London during the 60s. It was a fascinating time. So this point about the photographs on the moon couldn't have been taken there, I thought, well, that's interesting, because I'd watched the landings live on my little black and white television in London, July the 20th, 1969, 3:30 in the morning it was. A lot of people will remember having watched that. So I was convinced at the time that what I was watching was for real. So when somebody questioned it, I thought, oh, that's interesting. I'll check these photographs out. I had to go out and buy a set of postcards, because in the early 1990s, there wasn't such a thing as the internet, so I had to get books or magazines and look at the photographs there. I started looking at them, and if you study photography, you'll know how light affects a subject. And you can start to back-engineer a photograph. You can work out where the light was placed, how much light was there. If you know anything about photographic film, you know some of it is very sensitive to light, some of it is less sensitive, but it can record incredible detail. So I looked at the famous photographs of Buzz Aldrin climbing down the ladder from the Eagle, the lunar module, and I started saying, well, okay, I can see what this person might be referring to, because Buzz Aldrin is lit up like a Christmas tree in these photographs. And then you realize that he's actually climbing down in the shadow of the lunar lander, because the sun is the other side of the lander. Therefore, it's all in shadow. But he isn't. He's beautifully illuminated. It's a very good photograph. It shows you everything you want to see. And you can see all the detail in his spacesuit and his soles of his feet. And the more I looked at it, I thought, hang on a minute, there's something going on here, because I knew at that time that no auxiliary lighting had been taken on the Apollo missions. They were saving as much weight as they could. So what's the explanation for it? Oh, it's the sunlight being reflected off the super reflective surface of the moon. Well, on the face of it, that makes sense, until you start looking at it. Well, how much does the lunar surface reflect? And the answer is actually 8% of the light hitting it is reflected. So would 8% of the light hitting the lunar surface be enough to illuminate an astronaut wearing a white spacesuit and being recorded on photographic film, in this case Kodak Ektachrome transparency material? I knew from my own experience using Hasselblad cameras, which is what was being used, using Kodak Ektachrome film, how very sensitive it is to exposure. You have to get the exposure right or you ruin the shot. It's either too bright or it's too dark. I looked more at the photograph, and the directly illuminated surface of the moon, behind the spacecraft in this case, was not overexposed. But Aldrin was beautifully illuminated. And I thought, hang on a minute, there's a problem here. This photograph couldn't have been taken on the lunar surface. And I started looking at other ones, not just Apollo 11, but all the way through the other 6 missions that landed. And the more I looked at them, the more I realized that, yes, there were major problems with some of these photographs. They appear to show what I've subsequently discovered is actually a model. It's not on the lunar surface. Because film, as anybody who's used it will know, is sensitive to light. That's the whole point of film. It's sensitive to light. You have to get the exposure correct to ensure that you get the picture that you want. So all this light on the moon will be quite bright. There's no cloud or atmosphere to dissipate it. So it's quite bright. So how did they get the exposures correct all the time? Because they did. I've looked at virtually all the photographs. There are actually 5,771 photographs taken on the lunar surface by the 12 named astronauts, which is not a significantly large number of photographs, because it's quite easy to take photographs quite rapidly if you want to. Though the Hasselblad cameras were not automatic cameras. They were manually operated cameras, which is another thing. Once I discovered about that, I realized that no, we've got a major problem here, because these Hasselblad cameras, they're extremely good cameras, there's no doubt about that, but they are not automatic cameras. They're not point and shoot camera. That's what we use today. Switch it on, point it and shoot, and you get a good, well-exposed image, because the camera does all the work for you. On the moon, using the Hasselblad camera, you had to manually set the focus, you had to manually set the aperture setting, the f8, f11, f16, you had to manually set the shutter speed, 1/60th, 1/25th, 1/250th, And you didn't have a viewfinder, because if you're wearing a spacesuit, you can't get your head down low enough to look through the viewfinder, which on a Hasselblad is on the top of the camera. And you're wearing armored gauntlets in your spacesuit, armored against micrometeorite impact. So with all these limitations of use, some of the most defining images of the 20th century were taken. They weren't taken on the moon, they were taken here on Earth under controlled studio conditions by professional photographers. And if anybody can prove me wrong on that, I'd like to know. Because in 25 years of researching the subject, I've yet to have anybody give me any convincing case, or even any case at all, to say that they were taken on the lunar surface. Because there are two major problems when you're taking photographs on the moon. One of them is the radiation. It's not just radiation in the Van radiation belts which surround the Earth. They follow the lines of the magnetic field of the Earth, and they protect us from the radiation of space, as does our atmosphere. Once you're beyond the Van Allen belts, about 20,000 miles out, you're in what Neil Armstrong referred to as cislunar space, basically the area of space between the Earth and the Moon, which is the same as the space that surrounds the solar system. In that space, you've got solar particle events, solar flares, radiation from the sun, and you've got galactic cosmic rays coming from deep space, all of which affect photographic film. And you can't protect the camera from the radiation of space. You might be able to protect it from the temperature, which is quite severe in space. It's well over 100 degrees centigrade, higher than the boiling point of water, if you're standing in the sun. There's an even bigger problem in space. It's the vacuum of space. We don't have a vacuum here on Earth unless we create it. We're standing on Earth and we have 14.7 pounds per square inch of atmospheric pressure above our heads, which is 8 tons per square meter, which is quite a lot. We don't notice it because it's coming from all sides, so the only way we affect it, if we start driving our car too fast and we stick our hand out the window, you'll get the hand blown black, because the atmosphere is quite dense. In space, there is no atmosphere. There's nothing. It's a vacuum. And a vacuum has severe effects on photographic film. It has severe effects on a lot of things, but we're just talking about photographic film. If you have ever done those experiments at school with a vacuum chamber, and you've put a bowl of water in the vacuum chamber and you've created the vacuum, you'll notice the water starts to boil. Another word for that would be called outgassing. Any liquid will be boiled in a vacuum. And the other thing that happens in a vacuum, which is not really very well understood because we don't experience it very often here down on Earth, is called cold welding. Cold welding is, as its name implies, where you get two metals coming together and they will, in a vacuum, literally weld themselves together. It's caused by the outgassing of the lighter elements within whatever metal you've got, aluminium, magnesium, titanium. All of them outgas particles, and those intermingle if they're close to another piece of metal, right, and they in effect weld together. But there was no evidence of cold welding of these Hasselblad cameras, let alone the spacesuits. So we've got this major problem of the vacuum of space. We've got another huge problem of the radiation in space. But the photographs that we see taken on the lunar surface have no radiation damage to them at all. If you remember a few years ago when you went through airport security, they were using X-ray machines. You were always advised, if you had photographic film, to have them hand searched and not put through the machine, otherwise it would damage the film. Right. And you would normally protect them in a lead-lined box. So where are the lead-lined boxes on the moon? No, there weren't any. So there was no protection from the radiation of space on the photographic film. And there was certainly no protection from the vacuum of space, which would destroy film. As I say, some of the most defining images of the 20th century were produced. Yes, they were produced here on Earth, not on the moon.
But nobody ever has come out publicly and stated that they were part of this photographic moon hoax.
No, they haven't. You're quite right. And there's a very good reason for that, because there were 400,000 people working on the Apollo program at the height of it in 1966. And they were people working right across America, from Seattle, where Boeing were making part of the Saturn V and the lunar rover, down to Lockheed and Martin and over in Connecticut, where they were making the spacesuits, down at Houston, where they had the control center. All these people were working towards one aim, and they only knew about the job they were employed to do. The people working in Seattle didn't know about spacesuits. It wasn't their job to know about it. It's called compartmentalization. It's a military term where you know enough to do your own job. That's all you need to know. We all watched the same thing. We all watched the same piece of film of the rockets taking off. Those were real. But where they went 2 minutes after they launched, we had to rely on NASA to tell us what happened next. And for the next, in case Apollo 11, the next 8 days. Well, if we don't believe that everything that NASA tells you is true, because it stands for never a straight answer or no astronaut sent anywhere, then you have to start researching it yourself and looking into the detailed paperwork and the work that was done by the people working on it to find out if it all adds up. And in my opinion, it does not add up. That does not mean that these people were lying. They were not. They did not know anything about this. They only knew what they were doing themselves, because they couldn't get there for a start. Where's the evidence that they did land on the moon? Now, I've seen 80-foot gorillas climb the Empire State Building. I've seen dinosaurs chasing kids around kitchens in Jurassic Park. Is that real? Of course it's not. It's Hollywood at its finest. And Apollo is Hollywood at its finest. I'm not saying Hollywood was involved, because I can't prove it. But the film that we see, the Apollo record, and there's hundreds of hours of film, which you can go onto any number of websites and check out, has been deconstructed. And if anybody is interested in finding out the truth about how the Apollo hoax was perpetrated, or the film's part of it, there's a very good and very interesting and highly technical film called Make Believe Smoke and Mirrors. It's 2 hours 44 minutes long. When it was originally released about 5 years ago, the narrator of that film was so concerned that he didn't want to be identified that he disguised and distorted his voice to the extent you couldn't hear what he's saying. It's now been redubbed with a proper voiceover, and it's now available on a website, actually in Canada, called Apollo Detectives. So go on there, have a look at it, and see what you think. You'll see a few of my discussions with various people about it as well. Apollo Detectives on YouTube. The film Make Believe Smoke and Mirrors, it's a highly technical film, and it looks at how all the effects were created, the apparent slow motion. It's not just filmed and then slowed down so it all appears slow motion. No, it's far more complex than that. It's different speeds at different distances. It's the use of models and mannequins to create the environment. It's a stage set, in effect. It's quite a big stage set, but it's a stage set nevertheless. It was filmed here on Earth under controlled conditions, because it couldn't be filmed on the moon, because we've already covered the radiation problem affecting photographic film, and all the Apollo missions were filmed. They weren't all video, and the photographs, the still photographs taken by Hasselblad cameras, they were all filmed. And it's important to get the distinction between a film and a digital camera. Digital cameras didn't exist at the time of Apollo. How do we know that this is the case? How do we know that vacuum affects photographic film? Because that's hardly been mentioned as a problem. In fact, it's only in the last couple of years that it's actually come to be discussed at all, the effect of vacuum on photographic film. And that was a result of a lecture I attended here in London about 2 years ago, where the designer of the film cameras carried on the Hexagon spy satellite explained the details of his work. He was very proud of what he'd done. He designed and built the stereo cameras that were carried on the Hexagon reconnaissance satellite, let's call it, launched in 1971. And he mentioned, almost in passing, well, of course, the whole film had to be held in a pressurized container in the spacecraft, in the Hexagon spy satellite. I actually then asked the question, why was it pressurized? He said, very simple. Photographic film cannot work unless it is under a degree of pressure, in this case 1 pound per square inch. Not a great deal of pressure, the equivalent of flying at about 60,000 feet above Earth. That's 1 pound per square inch. At the top of Mount Everest, it's 5 pound per square inch. That's the pressure beyond which humans can't survive, because the pressure is not sufficient to force the oxygen into the lungs, against the back pressure of 14.7 pounds per square inch, which is the normal pressure inside the human body. So I asked him, I said, well, would pressurization be required to achieve the photographs we see on Apollo? He said, yes, of course they would. You can't use photographic film outside a pressurized environment. Now, the only other spacecraft that I was aware of at the time that used photographic film on the moon was the Lunar Orbiter craft, flying in 1966-67 to photograph potential landing sites for Apollo. And it carried photographic film on board. The film was contained within a pressurized environment on the spacecraft. It's no secret. Once you find the schematics of the Lunar Orbiter and the hexagon, you'll see it's identified. Pressurized container. It's nitrogen gas they used to keep the pressure. On the Lunar Orbiter, they did use photographic film, and it was developed on board the spacecraft by a type of Polaroid system which used liquids which have to be pressurized, otherwise they outgas and boil and don't work. The film was then scanned, and the scanned image was transmitted back to Earth, where it was reassembled back to make the photographs. And I've seen several of the Lunar Orbiter photographs. They're quite good. They got very high definition, and these are film. They're not digital, and those were the two craft that used photographic film in space, and both of them had to have pressurization to ensure the film maintained its integrity. So if that's the case, these photographs of astronauts walking around on the lunar surface doing all sorts of things were taken with photographic film, but they weren't taken on the moon. They couldn't have been. The photographic film would not have worked. The cameras were not pressurized. Now, whether man landed on the moon is another question, which maybe we can come to later. But so far as the photographs are concerned, no, they weren't taken on the moon.
I want to ask you this, sir, if you don't mind, and that is in regards to the technology that it took to get there. All right. I mean, it has been blown up over the last number of years that what we carry on our cell phone on a daily basis has more computers, more technology, more memory, more everything than the entire Apollo program had when they put their rockets into space. But one thing I have noticed with a lot of people who are my age and younger, the one thing that we do is we try and put yesterday's understanding of technology and mix it with today's technology with what we know. And we cannot comprehend the difference of how men and women made things work back then comparatively to how they make things work now. There's a giant confusion about that I believe is out there. What is your thoughts on that?
That's an excellent point, because that more or less sums up the problems that we have. Everybody wants to believe Apollo happened, but you do have to go back to the time it happened, mid to late 1960s, early 1970s, and look at the technology that was available to design the rockets, to design all the space suits, the control centers, the lunar rovers, all the technology that was used to allegedly get man to the moon. They actually used slide rules. In skilled hands, they're very, very good pieces of equipment. They're basically a form of calculator, but they are linear. So slide rules to me are a pretty ancient technology, but that was what was used to design the spacecraft. Slide rules. They didn't use computers. Forget computer-aided design. Forget it. Didn't exist. This is the 1960s. Things were very different. And as you say, it's very hard for people to get their head around the fact that cars did not have seat belts or airbags. They were extremely dangerous machines, actually, at the time. Not by just crashing into somebody, but by what was inside the car when you were thrown around during a relatively minor accident. You could get killed by it. Steering wheel was like a 6-inch nail pointing straight at your chest. But the technology that we have today is so far different, so far advanced from what we had just 50 years ago, 60 years ago, that if you're not familiar with it, it's very hard to get your head around the fact that that could have done what we are told it did. And I say that a great deal of it couldn't have happened, mainly because the technology was so primitive at the time. It was a miracle that even that 360-foot high Saturn V rocket, and by the way, it's called a Saturn V rocket because it had 5 engines, took off, and 1 million people watched Apollo 11 take off, disappear from sight. So then what happened? And how do we know what happened? We know what happened because NASA tell us. They were the only people who had access to the communication. And we're suddenly being told that we could communicate from the moon to Earth with these astronauts driving around, on the case of Apollo 15, 16, 17, driving around in the lunar rover. And It appears the technology is advanced, and many people can understand advanced technology, but they can't understand primitive technology. And this is actually primitive technology. The computers on board the Apollo command module, known as the AGC, the Apollo Guidance Computer, was a very, very primitive, by today's standards, piece of equipment. It could do certain things. It couldn't record anything. It didn't have the ability to record any information. The astronauts had to punch into it commands, which would then give an answer. But it couldn't then do anything. So the question arises, how on earth did they navigate? How did they get from the Earth to the Moon? Well, you can see the Moon, so you know where you're going. But there's a long distance between the Earth and the Moon, 240,000 miles. How do you navigate across that distance? Now, any pilot, anybody who's flown an aircraft, will know that piloting and following a particular path with an aircraft is actually quite complicated. You have to have radio beacons. In the old days of aircraft, you just followed rivers and roads, and you just hoped it was the right river and the right road, and you get to where you wanted to get to. Today, you use radio beacons, and you tune into radio beacon, and you can navigate across considerable distances, even across oceans. But the Apollo craft were navigating across a vast amount of space which had no features, so you didn't know where you were going. But we're told the computer did. No, the computer didn't. They were using a sextant. This is a 17th century device for taking star sightings if you're navigating across an ocean on a ship, to line up on certain stars. Obviously they know where the star is, and in relation to where you are, the star will tell you if you're on course or not. But it's very hard to change direction in space. You have to use a propulsion. And then we come on to Apollo 13. Oh dear. Oh, what a problem Apollo 13 is. Can we tell you the story of Apollo 13?
Let's get into it. We're already this deep into the pool. We need to do this now.
I think Apollo 13 is necessary because it's the outlier of the Apollo missions. There were 9 Apollo missions were sent to orbit the moon. Apollo 8 was the first one, totally untested. There'd be no test of the heat shield when it returned. Then you had Apollo 9, which was Earth orbit. Then you had Apollo 10, which was another orbit of the moon. Didn't land. Apollo 11 allegedly landed. Apollo 12 allegedly landed. And Apollo 13 didn't. Apollo 13 had an accident on the way. An oxygen tank exploded, we're told. That would have sent the craft so far off course, because every action has an equal and opposite reaction. If an oxygen tank exploded, it would be like firing a rocket. It would send it off in a different direction. But no, they didn't have a problem knowing where they were. They orbited around the back of the moon and landed back on Earth 8 days later, we're told. What we're not often told is the day after the official launch of Apollo 13, which was witnessed by many thousands of people, so it was for real. The day after Apollo 13 was officially launched, on April the 12th, in the Bay of Biscay, which is off the coast of France and Spain, the Soviet Navy recovered an Apollo command capsule from the Atlantic Ocean. They took it back with them to Murmansk, where the Atlantic Fleet is based, and 6 months later they handed it over to America on the US Coast Guard cutter, the South Wind, which was visiting Murmansk. What on earth was an Apollo command module doing floating in the Atlantic, being recovered by the Soviet Navy? It hadn't been reported missing. The official story is that it was what's called a boilerplate capsule, i.e. a practice capsule, not one that would go into space. I mean, this is for real. There are photographs of it being recovered from the Atlantic Ocean, being taken to Murmansk, being handed over to the South Wind, and you can go and see it now if you go to Grand Rapids, Michigan. It's on display outside their museum there. The official Apollo 13 command module, the one allegedly that had the accident and returned and all the astronauts survived and we all cheered and thought it was wonderful, is on display at the Kansas Cosmodrome. But you can't actually see inside it. You can't actually see very much. And the one at Grand Rapids, the alleged boilerplate, is sealed until the year 2076, the 300th anniversary of the founding of America. What's going on?